Question 4, and here we have another trig equation, this time in radians, 0 with angles between 0 and pi. And I'm just looking at that, there's been a bit of a mistake in the question sheet, and which I've just transcribed across, but that therefore should be an x, so apologies for that on the question sheet, that should be an x, not a theta. Okay, so we've got 6 sec squared 2x plus 5 tan 2x equals 12. The tan we're going to need to keep because it's not squared. The sec squared we can change, and we can change using the identity 1 plus tan squared theta equals sec squared theta. Okay, so sec squared is then replaceable with 1 plus tan squared. Okay, so straight away here then we replace that sec squared 2 theta with 1 plus tan squared, sorry, 2x, then plus 5 tan 2x equals 12. So now everything is in terms of tan. We've got our quadratic style equation, so we're going to expand the brackets. And then it's quadratic, so get everything onto one side, set n equal to 0, etc. in the right order, so the squared function first, then the tan on its own. Now 6 minus 12 is going to be minus 6. There we go. And so there we've got our quadratic equation. Now we could try and factorize that. It's a bit tricky. There seems to be quite a lot of options, but let's just have a quick look first of all to see if it's vaguely possible. So 3 tan 2x and 2 tan 2x. Okay. So let's see then, if we had a 9, so 3 times 3 is 9, and then we had 2 times 2 is 4, we'd be generating a sort of 5 difference there. So 9 minus 4 is 5, so that might be a way forward there. Now that would mean a positive 9 and negative 4, so 9 tan 2x minus 4 tan 2x gives us the 5 tan 2x, minus 2 times 3 is minus 6, 3 times 2 is the 6 there that we need, so that seems to work nicely. Or of course you can get out your calculator, go to the equation editor, option A there, this is a polynomial, degree 2 because it's a quadratic, put in your coefficients, so 6, 5 and negative 6, and the first solution should be 2/3. Now from my brackets then, that's going to be from this first bracket there, so tan x will equal 2/3. If this is correct, our second bracket, from our second bracket we're going to be getting minus 3/2, so this should hopefully tell us minus 3/2. Sure enough it does. Okay, so we know that our factorization is correct, and indeed we could have used this equation solver on the calculator to help us factorize it in the first place. Okay, so if the solution is 2/3, then you know it's of the form 3x minus 2. If the solution is minus 3/2, you know it's of the form 2x plus 3. Okay. Okay, now we're ready to then do some inverse tan work. So inverse tan of 2/3, being sure to remember to keep our calculator in radians there. Okay, so let's go back to the original. Now I want it in radians, so angle input is going to be radian to get the little r at the top there, and we're doing inverse tan of 2/3, and that's coming out as 0.588. Okay. Now we need to generate other angles, remember. So let's just do a quick sketch of the tan curve, or you could be applying your cast diagram at this stage, or just rules that you might happen to know off by heart for tan. Tan is quite easy. It's basically just plus or minus 180 degrees, or in this case plus or minus pi radians. to get from one angle to an equivalent next angle. But if you can't remember that, then you need to sketch the tan curve. Okay. So 0.588. Slight problem with this often is, oh, I've just put this in degrees, sorry. That's pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. Sorry about that. Yeah, the slight problem when you're dealing in radians is when you get these decimals like 0.588, well, what's that in relation to pi over 2? Quick check. Just work out what pi over 2 is on your calculator. As a decimal, 1.57. Okay, so 0.588 is clearly a lot smaller than 1.57. So that means, in fact, it's roughly a third, isn't it? So it's it'd be about there. 0.588. Okay, up, across, down. And hopefully you can see then if that's 0.588 there, that distance there is also 0.588. So you're just going to do pi plus 0.588. Okay, and if we're working from 0 to pi, that's like 0 to 180, even though we've got 2x, we're still going to only be expecting 2 answers from this, so that will be sufficient. But if you did want to, you could extend it and then calculate 2 pi plus 0.588 as well. Okay. Now, let's not forget the other equation that we generated here. Tan 2x equals minus 3 over 2. So from that one, (2x) is going to be inverse tan of minus 3 over 2. So minus 0.98279, etc. Minus 0.98279, etc. Now, that's then a minus angle, so we need to extend our graph back a little bit. There we go, so that's minus pi over 2. So pi over 2, remember, was 1.57, so that would be minus 1.57. This is minus 0.98, so that'll be there, somewhere around about there. Okay, so down. Currently, of course, that's even outside the domain. We've got a negative answer, which is outside the domain, so we're going to need to extrapolate inside twice. So that first angle there is going to be pi minus that 0.98279, etc. Extrapolate it along again and up, and again this time's 2 pi minus that 0.98279, etc. Okay, and similarly you could do 3 pi minus 0.9829279 if you wanted to. Okay, all a little bit messy when you're dealing in radians. Let's just summarize that then. So we had the 0.588. We're going to do to 3 significant figures here anyway. So 0.588, and it was 0, 0. Well, even when divided by 2, that's not going to overly affect anything. And in fact, the final answer should be to 2 decimal places, so that should be sufficient accuracy at that stage. Now, pi plus that. (3.729). And if you wanted to do 2 pi plus that as well, just go back and change that to a 2. 6.8711. Okay. So that was for the first angle. That was from the inverse tan of 2/3. From the inverse tan of 3/2, our first positive value would be generated from pi minus 0.98279, etc. So 2.1588. Similarly, go back to change that to a 2. 5.30039. And if you wanted to go back to change that to a 3, 8.4419, etc. Okay, divide all of those by 2. Might as well start with that last one. 4.22, and we're leaving it to 2 decimal places, remember, so we're going to have 1, 2, actually 4.22 is outside the domain anyway, actually. That's so 0.588 divided by 2, 0.294, 2 decimal places, 0.29. Okay, next up 3.7295, etc., divided by 2, 1.86. Next one, 6.87118. Now 3.43, we know that pi is 3.14 and we're only supposed to be going up to pi, so that then is going to be too big. So we'll cross that one off. So next one, 2.1588. So this time 1.08 to 2 decimal places. 2.65. And then similarly 8.44, etc. 4.22, so that's well above 3.14, so it's well above pi, so it's outside of the domain, too big, so cross it off. Okay, and there we go. There are 4 answers.